Introduction to Experimental Research. In our last unit, we started our exploration of quantitative methods utilized in the research that we read. This week, I want to go into kind of the largest subcategory of quantitative research, and those are experimental studies. We're going to spend the next several units looking at subcategories of experimental studies because there are a lot of different ways to arrange these studies, to utilize a variety of different subjects, placing them into groups, measuring multiple variables, and so on. So in this presentation, what I hope to do is give an overview of experimental research and talk about some of the concepts and some of the important features in experimental research that help to later define them into these subcategories. So the goals I have for this unit are to first off, allow us to begin to explore experimental research. And important to understand when it comes to experimental research is that we are investigating causal relationships. So we're attempting to say that A affects B, and those are typically going to be our variables. So we'll talk about how experimental research utilizes variables, independent variables and dependent variables, to look at causal relationships. So if we're trying to decide what type of foam roller is best, we can do an experiment to test different foam rollers and their effect on some aspect of performance, and that allows us to explore these causal relationships. So that's the first goal here, is to explore experimental research as it allows us to evaluate cause and effect. We'll also define what independent and dependent variables mean. We'll talk about sampling. We've talked about sampling in qualitative research, but now let's talk about sampling in experimental research, how we can divide people into groups, how we can collect data on these individuals, and then how we can analyze the data. Now, I said we're going to be looking at experimental research over the next several units. We'll spend a lot more time kind of diving into the actual statistical analyses that are performed in different types of experimental research, but we'll touch upon them here as well. Really importantly, I want you to understand the idea or concepts of a control group and an experimental group, a between subjects design, and a within subjects design, because we're going to see a lot of examples of each of these things, these concepts, these terms, in the literature that we read. So it's important that we understand how an experiment is set up and how it's gathering data with the subjects. And again, between subject and within subjects design are going to be important there. I want you to understand the term hypothesis and the concept of a hypothesis and how that allows a researcher to then conduct research and make a decision about that hypothesis or about that guess of what they may find. I also want to, again, touch on some inferential statistics and how we can test a hypothesis to see if we can have confidence in the differences that are found in the research that's performed. Along with hypothesis testing, we have to talk about the risk of making incorrect conclusions when research is performed, because there's always that chance, and we need to evaluate how big the chance is. And to do that, we have to understand the concepts of hypothesis testing, but also of error, specifically type 1 and type 2 error. So we'll spend some time going over that as well. And then finally, I want to talk about experimental studies as a whole and how we can evaluate their quality and their applicability to the types of questions that we may be wanting to answer to enhance our professional practice. So I understand that the majority of us are not going to be conducting research on our own. We're going to be reading it. However, I do think it's very helpful to kind of think about experimental research studies from the researcher's perspective. Like if you were creating a study, what would you want to do? What would you want to find out? And by understanding the process from the researcher perspective, that makes us much better at reading studies that have been performed by other researchers. So any researcher that wants to do a study, they have to first go out and find out information about the topic and formulate a research question. So, that's why every article that you read starts with this introduction that gives us a very brief glimpse of what literature is out there, what people already know. And what the researcher is attempting to do there is a couple things. First off, they're attempting to show how their question, what they're going to answer for us, will benefit our professional practice and help us treat our clients better and do a better job for them, or have a better grasp of physiology, which will secondarily benefit them, and so on. So that's what typically we see in the research in wellness and fitness, is that it's related to some aspect of professional practice or can be applied to improving our professional practice to the benefit of our clients and patients. Obviously, the individuals in this introduction, and if you're going to conduct research, you want to have a rich understanding of the topic and know the previous research that's been done before. By knowing what other people have found, we also know what they have not found, and we know where the gaps in our understanding exist. So it allows us to say, hey, how about if we do it this way? Or how about if we use this population? Maybe those things haven't been studied before, and that project can then kind of continue to build upon the research in our topic. Please remember, though, that any experimental research, the goal is to examine causal relationships. So we're attempting to look at the relationship between two or more variables and how one variable can affect another. So we are attempting to say that if I have my clients do this, then this will happen. And what we're hoping to do is find relationships that will lead to beneficial changes in our clients or improvements in our clinical practice. So we're going to be reading a study as part of this presentation, because I think it's really helpful to use a concrete example of an article to explore these concepts that we're talking about. It's an article that you've seen before in this course, and it's the article where the researchers wanted to examine the difference in effect of a vibrating foam roller and a non-vibrating foam roller. So we can see just from the title of this article, we can see some of the things I've mentioned. What we can see is this causal relationship that they're attempting to explore. The causal relationship involves the effect of vibration and non-vibration foam rolling on recovery. So they're trying to say that this has a differing effect on that. Okay, so it's saying that the vibrating foam roller will have a different effect potentially. That's what they're looking for in their experiment than the non-vibrating foam roller on recovery. So it gives us some guidance clinically, right? It says at the end, after we read this article, should we use a vibrating foam roller, a non-vibrating foam roller, or if no difference is found, doesn't matter. We can go with the cheaper non-vibrating foam roller. Now, they do use this term recovery. Recovery is not something that we can necessarily measure, so they're going to have to define for us what recovery means. But again, just the title itself gives us an idea of this causal relationship. So if I'm a researcher attempting to plan and implement an experiment, I first obviously have to find what we know and what we don't know and where gaps exist. I then start to design my experiment. The first steps in an experiment are going to basically be defining the variables, which is what I want to measure in my study, and specifically what grouping variables or treatments I might be using. Those would be examples of variables. And from that, I define a research hypothesis, which we'll talk more about in, again, another part of this unit. But basically, I want to identify what gaps in the research exist and how I can create a study to measure those gaps and measure some impact of performance. The variables that I'm going to create or look for or measure are often defined as either the independent variables and then the dependent variables. Typically, in most experimental research, we're looking at the independent variable to be the cause and the dependent variable to be the effect. So that we're saying that this thing over here, which often is a treatment or an exercise program or a new supplement or a diet, and we're saying that that has some effect on some other measure, such as maybe weight, fat-free mass, strength, endurance performance, sprint performance, whatever it may be. So we're trying to say that if we change this, then we get an improvement on this. Let's take a little bit more in-depth look at what an independent and dependent variable are. Because as we read research, you're going to want to always identify what these variables are. Typically, they're going to be explicitly stated by the researcher in the study that they've published, but we want to really look at these measurements because we want to see if those measurements are important to us. Are these independent variables treatment options for us? Are these dependent variables measures of performance or health or wellness that we are interested in or would like to help our clients improve in? So we have to look at these things. So again, what is an independent variable? Typically, the independent variable is going to be the causal agent in the experiment. So we're looking at the effect of this, which is the independent variable, on that, which is the dependent variable. Often in studies, the independent variable is a grouping variable or a treatment group. So sometimes the independent variable could be we're comparing men to women, or we're comparing high school athletes to college athletes. So the independent variable would be age group or gender. Most often, though, we see that the independent variable is a treatment group. So maybe we want to look at the effect of a novel 6-week-long endurance training program on performance of some aspect. So we have half of our subjects perform this 6-week training program that you've designed, the one you're interested in. We have the other half of the subjects do a traditional training program. And now our independent variable is training program with 2 levels, 2 different training programs. Maybe we want to actually have a third group, which is a control group that does nothing. So we want to see if there's any benefit to either training program, and then also if one training program is even better than the other. So that's typically a way that independent variables are utilized. You can have multiple independent variables. You may want to look at the differing effect of 2 training programs on men and women, because maybe you think this training program is going to have a greater effect for men or for women or whatever it may be. So you can have multiple independent variables. Most studies you're going to see, though, probably have one independent variable, maybe with several different levels of measurement. So there might be 3 training programs that they're looking at, or 3 foam rollers that they're comparing, and so on. The dependent variable is what we're looking for the effect to be. So we're looking at the effect of the independent variable on a dependent variable. The dependent variable you can think of as the outcome measurement. It's what happens to the people after the treatment or after the condition is applied. And again, you can have multiple dependent variables. So if again I'm looking at the effect of a 6-week training program, 2 different training programs, a novel one and a traditional one, on endurance athletes, I might have 2 dependent variables. One might be a 10,000 meter time, their best time, so performance in the 10,000 meters or 10K or something. We may have another dependent measure be VO2 max or average workload or something along those lines. So we can often have multiple dependent variables because we may be interested in different things. So again, if I was going to look at a strength program, I might want to be, in athletes, I may want to look at maybe their strength in their quadriceps, but also their 40-yard dash speed, because both of those can be impacted by strength, and both of those are important measures for me when it comes to enhancing performance in my athletes. So again, to summarize, the independent variable is usually the grouping variable, but is the cause that we're looking. And then the dependent variable is where we're looking for an effect. Now, we often find in research that there is no effect, that the independent variable had no effect on the dependent variable. That's still useful information. Again, if I am comparing 2 programs, both show a benefit, but there's no difference between the two, that means I have some more flexibility in my program design. So again, look for these studies, look to see what the independent and the dependent variable is, and then look at their conclusions to see if there was a causal relationship between these two variables or multiple variables. Now, a hypothesis is a really important term. What the researchers do typically as they are designing their study, they see where the gaps in the literature are. Based upon those gaps, they identify their independent variable, which would be their treatment, and their dependent variable, which is their outcome. They then create a hypothesis. A hypothesis is a predicted result. It's not what they're saying they think will happen, but it's a predicted result. So it's a prediction of the effect of the independent variable on the dependent variable. So again, you've read a bunch of literature. You see that high intensity interval training seems to be beneficial to a lot of different athletes, but it's never been studied on endurance athletes. So you create a hypothesis of that you think a high intensity interval training program will positively improve performance in the 10K or 5K, right? That would be your hypothesis. So a hypothesis is a prediction of an effect of an independent variable on a dependent variable. It's typically, the researcher is going to clearly define them. It's very similar to the research questions that you've been creating in this class. But again, a hypothesis is that it's the predicted effect of an independent variable on a dependent variable. Studies can often have multiple hypotheses, especially if they have multiple dependent variables. There's going to be a hypothesis sort of for each of the dependent variables, as well as the independent variables. Hypotheses can be non-directional or directional. What that means is a non-directional hypothesis says that there will be an effect of the independent variable on the dependent variable. It doesn't say what direction the effect is. So it might say that high-intensity interval training program will change the performance in a 5K. That's saying that there will be an effect, but it's not positive or negative. In the case of a training program and a particular outcome, typically we state it as a directional hypothesis, which says that it will be a change in this direction, meaning it will. Typically, our hypotheses are going to be stated as the inclusion of a high-intensity interval training program will result in an increased performance. That's a direction, we're saying the number will get better. Performance in the 5K, and so on. So again, hypotheses are that predicted effect of the independent variable on the dependent variable, and then that's what's measured in the study to see if there really is a true relationship between these variables.